Guys, so today we're gonna discuss about work, energy, power, work energy theorem, and how to calculate your electricity bill. So, let's go. Guys, so today we're gonna discuss about work, energy, power, work energy theorem, and how to calculate your electricity bill. So, let's go. So let's define work. Work is the product of the component of the force in the direction of the displacement and the magnitude of this displacement. Mathematically, the above statement is expressed as follows. W is equal to F cos theta. D is equal to force times displacement. W represents work done by the force. F is the force. D is the displacement caused by the force. Theta is the angle between the force vector and the displacement vector. What is the unit of work? The SI unit of work is the joule. This symbol is J, which is defined as the work done by a force of a newtons in a moving of an object to a distance of 1 meter in the direction of the force. The work done upon the weight against gravity can be calculated as follows. Work done, mass times acceleration times displacement. If you guys are wondering what is work, or force rather, force is defined as a push or pull that can cause any object with a mass to change its velocity and acceleration. Force is a vector of quantity and has both of magnitude and a direction. If the force of an object is zero, irrespective of the state of the object, dynamic or static, that work done by the force is zero. Or what is the displacement? Displacement is a vector quantity that gives us the shortest distance between the initial position and the final position of any object. If the resulting displacement in the direction of force due to the force acting on any object is zero, the net work done by the force on that object is zero. If we push the rigid wall in all might and still fail to displace it, then we can say no work has been performed by us on the wall. You know why? I'll explain to you more clearer. If you push the wall, of course, that is a wall. If you give your full force, the wall can't be moved. It means the wall is zero displacement and no work done. But this a lot of force. But if the displacement is zero, no work done. Moving on, energy. Our topic right now. After done discussing work, now we're gonna discuss energy. So what is energy? Energy is a scalar physical quantity that is associated with the state of one or more objects. Energy is generally defined as the potential to do work or produce heat. Sometimes it is like the currency for performing work. You must have the energy to accomplish work. To do 1 kilojoule of work, you must expend 1 kilojoule of energy. It must be added this interpretation can be misleading because energy is not necessarily available to do work. Energy can be transformed from one type to another and transferred from one object to another. Moreover, when transformed from one type to another and transferred from one object to another, the total amount energy is always the same. Let's have an example. For example, burning gasoline to power cars in an energy conversion process on rely on. The chemical energy in gasoline is converted to thermal energy, which is then converted to chemical energy that makes the car move. The mechanical energy has been converted to kinetic energy. When we use the brake to stop the car, the kinetic energy is converted by friction back to heat or thermal energy. Energy is then generally defined as the potential to do work or produce heat. This definition causes the SI unit for energy is the same as the work, which is the joule or the letter J. Joule is derived as the energy unit, unit of energy rather, and it is named in honor of James Prescott Joule. Moving on, power. Power is the rate at which work is done or energy is transferred in a unit of time. Power is increased if work done faster or energy is transferred in less time. The equation for power is P equals W per time. P stands for power in watts. W stands for the amount work done in joules or energy expended in joules. T stands for the amount of time. This is a T, not a plus. Since work is force times displacement, or W is equal to F times D, and velocity is displacement over the time, or V is equal to D times time, or per time rather. Power equals force times velocity, or P is equal to F times V, or the velocity. More power is seen when the system is both strong in force and fast in velocity. Power is measured in energy, or joules, is divided by time. Thus, a unit of power is the watt, or the W sign. In physics, W, which is W is equal to work or watt, or joule per second, J slash S. Power is a scalar quantity and it has no direction. Horsepower is used to describe the power delivered by a machine. I know that you heard about horsepower, about the machine, cars, the sports car, or any cars, or also the motorcycle. It is a unit of power in a British system of measurement. It is the power required to lift 550 pounds, yes, 550 pounds, by 1 foot in 1 second, and is about 746 watts. If you know the power of a system, you can find amount of work that will be produced as W is equal to PT. If a bulb has a power rating of 50 watts, it will produce 50 joules per second. In an hour, 3,600 seconds, it will produce 180,000 joules. Moving on, let's discuss work energy theorem. According to this theorem, when an object slows down, its final kinetic energy in less than its initial kinetic energy, the change in its kinetic energy is negative, and so is the net work done. If an object speed up, the network energy on it is positive. When calculating network, you must include all the forces that act on accomplish. Let's move on to work energy theorem. So, according to this theorem, when an object slows down its final kinetic energy in less than its initial kinetic energy, the change in its kinetic energy is negative, and so that is net work done on it. If an object speed up, the net work done on it is positive. When calculating the network, you must include all the forces that act on an object. If you leave out any forces that act on an object, or if you conclude any forces that do not act on it, you will get a wrong result. Yes, a wrong result. The importance of the work theorem, of the work energy theorem rather, and further the generalization to which it leads is that make it some types of calculations much simpler to accomplish that they would be trying to solve a Newton's second law. For example, in a second on Newton's second law, Newton's law of motion rather, we found the speed of an object sliding down a frictionless plane by solving a Newton's second law. For the acceleration and using kinetic equations for constant acceleration. So, moving on guys. So, ang didiscuss natin ngayon ay about power consumption or electricity bill. I'm sure madali mo lang itong matututunan. Kasi so far, ito lang yung natandaan ko. I mean, madali lang, hindi mo itong matandaan. Ito yung mas tanda ko. So, ito. So, for example natin guys. So, liwanag masyado. So, ayan. Wi-Fi. 3 watts. Yan. Ang 3 watts na to is itong Wi-Fi. Watts ito ng Wi-Fi. And then, itong nakikita yung 24 hours. Yan. Hindi ko alam kung maayos nakikita or baliktad. 24 hours po to. Yan. 24 HRS. 24 hours. So, ang gagawin nyo dyan, kuhain nyo muna. Kumuha kayo ng isang bagay. Tapos, hanapin nyo yung watts nun. Tapos, itong hours naman is, ito yung estimated hour na yung ginagamit yung gadgets na yon. So, ayan. Ang gagawin nyo, pagta-times nyo yan. Times nyo. Ayan guys, bibigyan ko pa kayo ng iba example mamaya. So, basta kuha lang kayo ng scientific calculator. So, ito. Then, gagawin nyo pagta-times nyo yan. 3 times 24 is equal to 72 watts per hours over 1,000. 72, ito 72 divide by 1,000. Ito guys, 1,000 given na to. So, given na yan. Yung kailangan kuhaan nyo sa iba kasi given na to. So, 72 divide by 1,000 is equal to 0.072 kilowatts per hour. Kilowatts per hour. 0.072 kilowatts per hour. So guys, baba nyo lang dito yung kasi pwede ko pa namang idiretso kaso wala po tayong whiteboard. So yan, 0.072 yung sagot dito kanina. Yan, 0.072 kilowatts per hour. Ito naman po yung araw. Ilang araw ba meron sa isang buwan? Kalimitan kasi 30 days, di ba? Minsan 31 kasi ito yung kalimitan eh. Ayan. 30 days sa kalendaryo. Kahit gayahin nyo na din to guys, 30 days. So, ang gagawin nyo, yung sagot dito, sa pinag-types yung 72, pinag-divide, 72 divide by 1,000 is equal to 0.072 kilowatts per hour. Gagawin nyo dyan guys, yung sagot na yun, ito times nyo sa buwan. Kung ilang araw meron sa isang buwan. Kalimitan, di ba? 30 days. So, 0.072 times 31 days is equal to 2.16 kilowatts per hour. 2.16. Guys, nakaka-follow ba kayo? Okay, paki-raise hand naman. Hindi pa, joke lang mo. So, ayan. Itong lalabas dyan, 2.16 kilowatts per hour. 2.16. Pero basta lalagay niya sign palagi na kilowatts per hour. 2.16. Ito, babae dito. 2.16. Kapin nyo lang. 2.16 kilowatts per hour. Ita-times ko siya dito sa PHP or pesos. 10.59 pesos. Ito kasi makikita nito sa bill nyo mismo sa kuryente. Kasi nagbabago-bago to eh. Kasi ito lang, kunyari, for example na ito yung nakalagay, 'di ba? Makikita niyo sa electric bill nyo. So, gagawin nyo, pagka-times nyo lang yan. Times nyo lang yan guys. Yung 2.16 kilowatts per hour times 10.59 PHP is equal to 22.87 ganon. So, ito na po yung final na answer niya per month. Guys, ba guys? Ito po yung nakakuha niyang nakakonsap niya na pera or bill. Itong wifi, kasi mababa lang siya. 24 hours lang ginagamit sa akin. 30 days. So, ayun. Sa isang buwan po, ang gagastos nyo, binabayadan nyo sa wifi na to, or sa amin, wifi, ay 22.87 pesos po. Per month po yun, per month. So, I will give you another example. So, here's another example. So, ang kinuha ko naman, ito, lagyan natin. Ayan, ref. So, sabi ko nga kanina, first kukunin muna natin yung watts. So, makikita nyo naman yan sa likod or sa harap. So, may nakalagay lang doon, may nakakapit. So, ang ref namin ay, ang wattage niya ay 234 watts. So, yan. Tapos, kukuha nyo din syempre yung hours yung estimated hours nyo kung ilang hours yung ginagamit or minutes, ganun. So, syempre yung ref, hindi na namin binubunot. Masira yung pagkain, di ba? Sayang. So, lagay natin, syempre hindi namin binubunot. Ilang bang oras meron sa isang araw? Di ba? 24 hours. So, lagay natin 24. HRS, so, hours. So, ayan. Yan. Yan. Ito, pagka-times nyo lang yan, yung wattage, ito, yung wattage ng ref, which is 234 times 24 hours. So, ito. Ito natin. 234 watts. Kahit di nyo na isama guys yung watts, yung symbol sa pagka-compute. So, gawin nyo lang 234 times 24. So, yan. Ang lumabas ay 5,616. So, ayan. Grabe, laki 5,000. So, lagay natin dito sa gilid. Parang mabibitin 5,616 over 1,000. Kasabi ko nga lang kanina, yung 1,000 ay given na yan. Given na to. Itong sagot na to ay nakuha dito sa 300, which is, ano nga ito? 234 wattage ng ref. At yung estimated hours, yung ilang ginagamit, 24 pinag-times nyo lang yan, multiply. Then, ito yung lalabas na sagot. 5,616 over 1,000. Ang gagawin nyo lang dyan, guys, ay division lang. 5,616 divided by 1,000. Wait lang. 5,616 mali. 5,616 divide by 1,000. Ayan. So, ano lalabas na sagot? 5.6616. So, dapat dito yan. So, lagay na lang natin sa baba kasi wala akong whiteboard. Hindi kasha. So, lagay na lang natin sa baba. Ayan. 5.616. So, siyempre, lagay pa lang natin yung symbol. Ito, nakalimutan natin yung wattage per hour. Yan. Wattage per hour. Ito naman, anong nalagay dito? Nakalimutan ko. Kilowattage na to. Yan. Kilowattage per hour. Kilowattage per hour. Yan. Kilowattage per hour. Tapos, ang gagawin nyo naman dyan ay ita-times nyo yung sagot sa 5,616 over 1,000. Pag-divide nyo, yung sagot na lalabas doon, di ba? 5.616. Ang gagawin nyo doon, yan. Ita-times nyo yung 5.616 sa 30 days. Yan. Guys, yung ulitin ko yung 30 days, yun yung kalimitang ilang araw meron sa isang buwan. Kasi minsan may 31, 30, pero kalimitan 30, diba? So, ayan. Pagta-times nyo lang ulit, tapos equals, diba? Times natin yan. 5.616 times 30. Ayan. Ito na ba? Ano ba sa sagot ay 168.84. 0.48 pala, sorry. Tao lang. Yan. Siyempre, lagay pa din natin yung kilowatts per days na yata to. Per hour pa din. Sige. Kasi ito guys, ngayon ko lang to kinompute. Ang sunod naman doon, yung kalimitan na binibigay or makikita nyo naman sa electrical bill nyo kung magkano yung consumption, yung consumption sa bill. Makikita nyo yun kasi papalit-palit sila tulad ng kanina. Yung kanina pa din yung gagamitin natin. Which is, ito. Yung 10 PHP 10.59. 10.59. Yan. Makikita nyo naman to sa bill nyo. Gagawin nyo, multiplication ulit. Yan. Multiplication ulit yan. So, multiply natin. 168.48 kilowatts per hour. Kahit din nyo na ilagay yung symbol. Times 10.59. Yung kalimitan ng binibigay sa bill. Hindi mo kalimitan kasi pabago-bago din. Ewan ko lang din. Pero given, parang given na to. So yan. Ang lumabas ay grabe. Ang laki na to. Ito guys yung lumabas. Yan. 1,784.20. So yan. Lagay muna natin. PHP 1,784 0.20. Lagyan natin ng kompleto. 20, 32 PHP per month. Yan. So, ito yung lumabas na sagot. Yan. Ito. So, bale, yung nako-consume yung binabayadan nyo dito sa ref, sa amin, kasi iba't iba naman tayo ng wattage ng ref, iba't ibang kung gaano kalaki, at iba't ibang oras, yung iba kasi binubunot. Tapos yan, yung per month yung binabayadan dun sa ref namin, ay 1,784.2032 per month. Per month to. So, grabe, ang laki, no? Yan. So, yun lang guys. Sana natuto kayo. Yun lang. Thank you!